Today the topic that today the topic that we are going to cover is uncertainty calculation. Now, in uncertainty calculation, we have to see the calculation of systematic uncertainty and the calculation of random uncertainty. First of all, calculating systematic uncertainty. So the first thing is calculating a systematic uncertainty. Now, to calculate systematic uncertainty, the method is, first of all, you need to calculate the average of the data. So this is the first thing. First of all, you must calculate the average of the data, and then systematic uncertainty will be equal to the average value minus the actual value. So if we subtract the average value minus the actual value, then we'll get the systematic uncertainty. So, and one thing, systematic uncertainty could be positive or it could be negative. So systematic uncertainty will be positive if average is bigger than the actual value. So if you get a situation in which the average of the data is bigger than the actual value, then the systematic uncertainty will be positive. And you can also have a negative systematic uncertainty. So systematic uncertainty will be negative if, so you'll get a negative systematic uncertainty if the average is smaller than the actual value. Now let's solve some examples for systematic uncertainty. Example number 1. Example number 1. Accepted value of G in a region on the earth is 9.81 meter per second square. No, what is this? This is the true value. For any experiment, the value that is accepted by the majority or the common accepted value is called the true value. Now, an experiment is performed. An experiment is performed to find smaller g. The repeated values, the repeated values were 9.4, 9.6, and 9.8 meter per second square. So you calculated G by repeating the experiment twice, and the three values that you achieved are 9.4, 9.6, and 9.8. Now the question is, calculate systematic error. Now the first step is calculate the average of the data. Calculate the average of the given data value. Just for example, G average will be equal to, for the given values, the average value of G would be 9.4 plus 9.6 plus 9.8 whole over 3, and it would become 9.6 meter per second square. So this is the average value of G. Now let's calculate the systematic uncertainty. Now the systematic uncertainty would be according to the formula, systematic uncertainty would be the average value minus the actual value. So the systematic uncertainty will be equal to the average value minus the actual value. So you have average value as, you see, it is 9.6 and the actual value is 9.8. So it would become 9.6 meter per second square minus 9.81 meter per second square, and the answer would be negative 0.2 meter per second squares. And the least precise value has one decimal, so the answer of subtraction should have one decimal point. So this was an example of calculation of systematic error. In this example, average 9.6 was less than the actual value. That's why the uncertainty, systematic uncertainty is negative. If you look carefully, this average is smaller than the actual value. That's why systematic uncertainty is negative. Now, one more example. An example is an experiment. An experiment is performed to calculate mass of a person. So you perform an experiment to find the mass of a person. Repeated readings were 64 kg, 65 kg, and 66 kg. You took 3 trials of the reading. You repeated the experiment twice, and you got the readings 64, 65, and 66 kg. Now the question is, calculate systematic uncertainty. This is the question. So calculate systematic uncertainty. And answer to this question would be, you see, in this experiment, the actual value is missing. So the first thing is, in the given experiment, actual value is missing. So you have no idea what is the actual mass of the person. Hence, systematic uncertainty cannot be calculated. So one thing should be clear. To calculate the systematic uncertainty, you need the actual value. Here, the actual value is missing, so you cannot calculate the systematic uncertainty. Now, let's calculate random uncertainties. Calculating random uncertainty in a reading, and then calculating random uncertainty in a measurement. Here, reading will be the raw data that you take from the instrument, and the measurement is values calculated from the readings. Now, first of all, random uncertainty in the raw data taken from the instrument. Let's go for some examples. Random uncertainty in a reading. The method is calculate the average value, then the difference, then the difference of individual, then the difference of individual readings from the then the difference of individual readings from the average value. So first step is calculate average. Then calculate the difference of individual readings from the average value. These are called deviations. And the last step would be calculate mean deviation. Then you are supposed to calculate the mean deviation, and you must know that your random uncertainty will be equal to plus minus mean deviation. And one thing should be clear: for the calculation of random uncertainty, actual value is not needed. You need data points, and that's it. From data points, you can calculate the random uncertainty, unlike systematic uncertainty, which needs the actual value to be there. So, even if the actual value is missing, the random uncertainty can be calculated. Let's solve an example for that. An example for the calculation of random uncertainty. You calculated mass of a person for 5 times, and the readings are 62, 63, 64, 65, and 66 kg. So you repeat the experiment for the mass of the person and you get these readings. I took a simple data to keep the calculation simple. However, for complicated data, the method would remain same, and you need to understand the method. That is the main thing. Now, if you see, the average of this data would be 62 plus 63 plus 64 plus 65 plus 66 whole over 1, 2, 3, 4, 5. And the answer would be 64 kg. So the average value of this data is 64 kg. Now, for the calculation of random uncertainty, you need to calculate the deviations. First of all, your data points were 62, 63, 64, 65, and then you have 66. Now you see the average was 64. Calculated the average and it was 64. Now calculate the deviation of each point from the average. and ignore the sign of deviation. Just calculate the difference. Here it is 2. Here it is 1. Here it is 0. Here it is 1. Here it is 2. Now, this is the deviation of individual points from the average. 2, 1, 0, 1, and 2. Now calculate mean deviation. The mean deviation is, you see, 2 plus 1 plus 0 plus 1 plus 2 whole over 5. So it would be 6 over 5, and the answer would be 1.2. And the answer would be 1.2. Now you see the mean deviation is 1.2, and we can say that the random uncertainty in the given experiment is plus minus 1.2 kg. However, random uncertainties are written up to one significant figure in A1 syllabus, so it would become finally plus minus 1 kg. Now, how will you record the data? Your average was, you see, 64 kg, and your random uncertainty is 1 kg. Now you write m is equal to 64 plus minus 1 kg. This is the method to record the data with random uncertainty. Actually, when you taken the readings for mass, the values were fluctuating. So what you did, you calculated the average, then you calculated the mean deviation, and the average value of mean deviation, that was plus minus 1 kg, was a random uncertainty. So let's solve one other example. Here you see, for the calculation of random uncertainty, we do not need the actual value. It is just the data points which are used. So first step is calculate the average. Then calculate deviation of each point from the average, ignoring the sign. Then calculate the mean deviation, and your mean deviation is your random uncertainty in a certain reading. Let's suppose you calculate length of a duster and you get the readings 9 centimeter, 8 centimeter, then you get 10 centimeter, then you get 11 centimeter, and then you get 12 centimeter. Now, these are the data points for the length of a duster. The question is calculate random uncertainty in the length of the duster. So the question is calculate the random uncertainty in the length of the duster. Now the first step is calculate the average value of the length. You see, the average value of the length would be 8 plus 9 plus 10 plus 11 plus 12, and in total you have 6 values. 1, 2, 3, 4, in fact 5 values. Divided by 5 and you'll get 10 centimeter as the average value. Now 10 centimeter is the average of the length, and 10 centimeter is the average value of the length. Now you have average. Now you need to calculate the mean deviation. Just for example, this value is 9 centimeter. In fact, the first value is 8 centimeter. Then you have 9 centimeter, then you have 10 centimeter, then you have 11 centimeter, and then you have 12 centimeter. So these are your values, 8, 9, 10, 11, and 12. Now your average value is, you see your average value is 10 centimeter. So 10 centimeter, 10 centimeter, 10 centimeter, and then you have 10 centimeter. Now if you take the deviations, here you get 2 centimeter, here you get 1 centimeter, 0 centimeter, 1 centimeter, and then you get 2 centimeter. Now if you calculate the mean deviation, the mean deviation would be, it would be 2 plus 1 plus 0 plus 1 plus 2 whole over 5. So the answer would be 6 over 5, and that would be 1.2 centimeter. Now you know the random uncertainties are written up to one significant figure, and it would become plus minus 1 centimeter. Now, how will you state the reading for length of the duster? It would be stated as 10 plus minus 1 centimeter. So this is the value for the length of the duster. So whenever you have to calculate the random uncertainty, take the average value, then take the deviations. After calculating the deviations, calculate mean deviation, and here the mean deviation was 1.2 centimeter, but the random uncertainties are written up to one significant figure. That's why it is written as plus minus 1 centimeter. Up till now, we have seen how to calculate the random uncertainty in the raw data or in a reading. Now, calculating random uncertainty in a measurement. Calculating random uncertainty in a measurement. This is a topic that we'll cover tomorrow. Up till now, we have seen two things: calculating systematic uncertainty and random uncertainty in the data values. Now, for the calculation of systematic uncertainty, you need the actual value. Without having the actual value, you cannot calculate the systematic uncertainty. However, the random uncertainty can be calculated even if the actual value is missing. So this is the topic for today, and we'll start the calculation of random uncertainty in a measurement tomorrow, inshallah. Take care, students. Khudafez.